Sounds good.
Right. Yeah.
Okay, hey everyone. It's me, Jordan from Dimensional Labs again. So today's lecture is on Candid. So let me share my screen and we'll dive in. All right. Is it shared? Yeah, I think it's shared. Okay, so Candid. This is a new language that Dfinity created for the internet computer ecosystem. This is not a general purpose programming language. It's not like TypeScript or Python or Rust or Motoko. It is what we call, if you look right here, an interface description language or an interface definition language, IDL. And as it says here, it can be used to define interfaces between services or canisters, allowing canisters and clients written in various languages to easily interact with each other. So that is the main purpose, is to allow interoperability between canisters and clients on their computer, no matter what source code, general purpose programming language they're written in. As long as they understand the interface of the rest, then they'll be able to communicate. And what do we mean by communicate? Basically, calling functions on canisters, right? To call a function on the internet computer, you need to understand the specific data types of the parameters for the function and for the return type. I mean, technically, you don't need to do this. You don't need to use Candid if you don't want to. Your functions can just deal in a raw binary, but that's going to be very difficult to deal with. So Candid just allows us to have a really, really nice developer experience by making it really, really easy to serialize and deserialize between all these data types that you see here. So today we're in chapter 11 of the ASL book. And also, I really highly recommend the Candid reference on the internetcomputer.org docs. We heavily use this reference to write our own materials and to make sure that we're supporting basically everything that Candid can support. So yeah, you can use these two references, and these are all the types that Candid provides, right? At least according to the documentation here. So some of them are quite simple. You'll be familiar with them. So we'll just go through them one at a time. So first one is text. The Candid text type in ASL is represented by the TypeScript string type or the ASL text type. So you can use either or. And under the hood, at runtime, it will be a JavaScript string value. So let's show how this can work. Yeah, if you just want to return a string, you can just use the built-in TypeScript string type, or you can import the text type from ASL, and these are equivalent. There's no difference between them. You will generate the same exact Candid, and the functionality will be the same. So that's text. Next, we have blob. The ASL type blob obviously corresponds to the Candid type blob, and at runtime, it is a JavaScript uint8 array. So a uint8 array is a typed array in JavaScript. It provides certain efficiency and performance benefits over just regular arrays. And every element is going to be an unsigned 8-bit integer. And that's exactly what the blob type is in Candid. If we go look at blob, it can be used for binary data, sequence of bytes. And in Candid, blobs are the same thing as vectors of NAT8. So NAT8 is the natural unsigned 8-bit integer type, and then a vec is just a vector or array of that. So blob is the same, but in ASL, we highly recommend, and I think we're going to make this an error eventually, but we highly recommend that you only use the blob type. Do not try to use vec and NAT8 to make a blob, and I'll show you why. So if we use the blob type, I'll zoom in, sorry. If we use the blob type, then TypeScript expects a uint data array. So it says here, string is not assignable to type uint data array. So you need to actually make an actual uint data array, and then you're good to go. But if you use vecnet8, the types are not quite right. So it will actually tell you that you need to use an array with basically just numbers inside. It is just technically not correct. So that is just one difference you run into. So if you want bytes, just use blob, and everything should be good. There you go. And yeah, if you have params of type blob, then it will come in as a uint data array. And this will be the most efficient way for you to deal with binary data. All right. Next, we have the nat type. Hazelnut. I guess I should zoom in here probably for you too. So hazelnut and corresponds to the Candid net. At runtime, it is actually a JavaScript big int. So JavaScript actually has a built-in big int type, and that's what it'll be for you. So you can see here, this is the biggest big int. Or this is the biggest, probably not the biggest, because I think they're unbounded. Let's go check. So if we go to the nat type in Candid, the nat type contains all natural non-negative numbers. It is unbounded and can represent arbitrarily, I would say, large numbers. So I believe that the JavaScript big int is also arbitrarily large, but you can go read the documentation on big int to understand that. And you can make big ints by using this little notation here with this n. So there's actually a couple ways to do it. So let's import nat, and these are all imported just straight from Hazel, unless they're built in. Okay, so far this is just a number, but if I add this little n literal thing, now it's a big N. And you can also do it like this if you want. I much prefer this. It's very simple. Okay, nat64, and we'll just cover all the sized types together, but nat has all of its subtypes, so it has nat64, nat32, nat16, and nat8. Nat64 under the hood will be a JavaScript big int. And why is it called 64? Well, if we go check it out over here, the types nat8, nat16, nat32, nat64, and the integer ones as well represent numbers with a representation of that many bits and can be used in more low-level interfaces. So, it just tells you the actual size in bits of those numbers. Like I said, under the hood at runtime in JavaScript, it won't necessarily follow these same sizes. But the Candid serialization and deserialization, the Candid type checking basically, will prevent you from sending values that are too small or too big, basically too big. So keep that in mind. So we'll just skip nat32, nat16, nat8. Okay, int. Int is also a big int at runtime, but the int type contains all whole numbers, so they can be negative. So if you need negativity, then you can get that. And then int64, 32, int16, and int8 are as you'd expect. Now, I feel like it's always confusing, like trying to decide which numbers to use. So to keep it simple, I mean, maybe just start off by using just nat for everything, right? And then if you discover and it becomes apparent to you that nat does not work for whatever reason, like, oh, I need negative numbers, then switch to int. Then if it becomes apparent to you that, I don't know, these numbers are taking up too much space, or you want to have some error checking to make sure people can't put numbers that are too big or something, just let the requirements of your application guide you. For the purposes of this weekend in the DAO, I mean, I would just make it simple on yourself and just use nat or int. Okay, then we come to the float types. Everything we just talked about were in integers, right? They do not have decimals. There's no dot, 0, 1, 2, 3, or whatever after the number, but floats do allow you to do this. The ASL float type, float64, is going to be under the hood a JavaScript number, which is an IEEE 764 floating point number, I believe, 64-bit. And it represents the Candid float64 type. And something cool is the JavaScript number type is automatically a float64. So if you do want to just use number and you're okay with floats, then you can do that. Or you could explicitly import float64, and these are equivalent. So either way, do whichever you like. Okay, float32 represents obviously the Candid float32 type and is also a JavaScript number. Keep in mind though that it is a JavaScript number under the hood, so it's not, like we've talked about, it's not actually going to be scoped to 32 bits at runtime, but with Candid serialization and deserialization, I believe Candid will enforce the 32 bits for you. And there's obviously more information here. These are both IEEE 754 floating point numbers, but you have 32-bit and 64-bit choices. So again, if you need floats, maybe just use number, right? The TypeScript number type or float64. And if you need float32, then hopefully it becomes apparent to you. I would not get too worked up about all these types unless you absolutely know that you need them. Bool is simple Boolean. We just use the TypeScript Boolean type, so true or false, nothing crazy. Null is null. Nothing crazy there. Vec, so in ASL, you need to import the vec type and use it like this. Don't try to use the array syntax, so let me show you. If I want to make a array of float64s, you do it like this. If I want to return an array of float64s, you do it like that. Don't do this. Doesn't work. Don't do array. That doesn't work. You need to import the vec type. And then you make arrays like you owe to. Yep, it will be a JavaScript array at runtime, except for vecnat8. Remember, do not use vecnat8. Only use blob. Okay, the opt type. This one, you should really pay attention. This is quite different probably than anything you've ever experienced, unless you're familiar with Rust or Motoko, or any other language that has algebraic data types. So the ASL type opt corresponds to the Candid type opt. It is a variant. Remember, we did talk about variants in the first lesson. A variant is basically an enum. It has a number of fields or branches or tags. And at runtime, when you actually have a value, it will only be one of those things, right? It's an enumeration. So an opt is a special type of variant that only has two arms or branches, some or none. None means there is no value whatsoever. And some means there is a value and you can get the value out. At runtime, an option will be a JavaScript object with either a some property or a none property. I will show you, we'll do some coding with this real quick. Let me show you in the Candid documentation as well. Opt T, it's a little esoteric, but all the values of type T, so basically any value. And in Candid, you either have opt that value or null. In Rust, and I'm not sure about Motoko, but in Rust, you use the option type, which should be some or none. And ASL, we decided in this case to follow very quickly, or very closely to Rust, and to just embrace this algebraic data type, and we have some or none. It is used to express that some value is optional, meaning that data might be present at some value type T or might be absent. And you can nest these, so you can have ops of ops of ops of ops, And like it says here, the opt type plays a crucial role in the evolution of Candid interfaces and has special subtyping rules as described below. So opt is very important. Okay, so let's show how to use it. Let's just do a return type with an opt. Let's say it's opt number. So let's say this function, let's say you only want to, you just want to say that there's nothing to return from this function whatsoever, right? Then you just say opt. Done. Let me show you, let me deploy this and show you what it looks like. So this is the showing the absence of value, opt.none. There's another way you could do this. You could do this. That's like the more manual way of doing a variant. But we provided this nice little abstraction for you. So opt.none will return candid null. And opt.sum will return an opt with a value in it. That's the basic concept, and then I'll show you nesting. There's nothing too crazy. It's just like, if you really want to understand this, especially if you're new, you might be concerned or not think it's a good idea. But algebraic data types are a concept that Motoko has embraced, that Rust has embraced, that ASL is trying to embrace, that it seems Candid has embraced. That just provides some very nice benefits. Okay, so in this case, it's an opt with the actual number inside of it. And then you can nest these arbitrarily as well. Yeah, you can just keep nesting those if you want. So yeah, I mean, oftentimes you just need to express this concept of not having anything, right? And so if you need to express that in your canister interface, use opt. It'll be much nicer to work with than like just trapping or let's see, we've nested and trapping or like returning an empty string. A good example of this would be if we made like a little database in here. And let's say we want to get values, like a key or string. I'll make that a little database type. The keys are strings and the values are strings. DB will be of type DB. And let's say we want to return DB key. Well, the problem is that the value might not exist, right? So, I mean, you could say something, you could use, in TypeScript, you can use union. So you could say, well, it'll return a string or undefined. Right? And that could work in TypeScript, that doesn't work in ASL. You could just say, well, it returns a string, and then if it is undefined, you could throw an error or something. But I guess what we're recommending is that you basically do this. And yeah, if the value, well, let's see. Value's undefined, then you can return off, and then otherwise return off sum. So, I mean, yeah, you just really need to study the algebraic data types to get to the essence of why they're useful, but it is a little more verbose sometimes. But there you go. That's what I recommend. Okay, that one's a little complicated, so I just want to pause. Are there any questions about opt? Okay, then we'll move on to record. So record is going to be your main non-primitive data structure that allows you to create arbitrarily nested or complex objects, right? Plain data objects. We're not talking about object-oriented programming or classes or anything. We're just talking about plain data objects that just hold payloads of data. And it's pretty simple, right? You just import record from ASL, and then you name your fields with your types. Keep in mind, your types must also be Candid compatible because the record must be serializable to Candid and deserializable from Candid. So that means you can't have fields that aren't also following the rules. So you need to use all of these Candid types in your record. But I think it is pretty straightforward. Once you import the record type, you just make a type alias to that type, and then inside of the record type, you start. You just use an object literal, and you define the key names and then the actual types on the right-hand side. And then you can use them or release it, right? Like get user, you got a user right here, and you just make an object literal and put your actual values in. And you can receive them obviously as parameters, return types, anywhere Candid values are used. Basically, you should be able to use these records. I haven't been showing you the Candid, but you can see the actual Candid right here that will be generated for you, which can be consumed by other canisters or clients so that they are also able to communicate with your stuff easily. Okay, now we come to variant. We talked about opt already quite a bit. The variant is going to be the generalization of opt, so you don't need. You can make your tags here or your branches or arms any value that you want. Again, I highly recommend looking up algebraic data types to get the hang of why they're powerful. But in Rust or Motoko, they have really powerful compiler. The compilers are going to just make sure that you handle all your values explicitly. In ASL, we're trying to help you do this. We've made a special function called match that should help you. So this is the basic concept. So let's dive in and show you how to use these. Okay, so you'll just for variant. Let's do like in the thing reaction. We have fire, thumbs up, and emotion. So we'll keep all these null. If you don't need your arm to have a value, you just say null on the right-hand side. Just do this for now. Okay, it's a very, very basic variant. Make a function called getReaction, and we'll return a reaction. Okay, so the important piece here is it can only be one of them. So it can be fire, or thumbs up, or thumbs down. But what's nice is the compiler will tell you if you do something wrong. So, nope, you cannot have two of these. You can only have one. So it's trying to enforce this variant on you. Also, if you receive a variant, there's a special function that you can use called match. That will help ensure that you handle every possible branch. So we know that reaction will only have one of fire, thumbs up, or thumbs down at runtime. So how are you going to basically branch off that? And that's what the match function will do. It will force you to have a handler for every single one of these. Okay, so now it's happy. It's void because these all return void. So let's say you're just trying to turn it into a string or something. Okay, you can do any kind of functionality that you need. And now result will be a string. And you'll know that you've handled everything. You shouldn't get, crazy errors where you didn't, some undefined behavior or unexpected behavior because you didn't handle every single case. This match function is, you can decide how you want to do it, right? So I like the match, but sometimes you might find it less verbose to just do something like this. You can just do if statements for all of these as well. Though, if you do that, you might find that you get into weird cases with your return statement because you'll handle every case, and then you'll have one more case at the end that isn't handled. So I'll show you how that looks. Let's say I want to handle fire, thumbs up, and thumbs down. Also, the compiler's not telling me if I'm using if statements. I don't know if I've actually checked everything. I'm just assuming I have. So return something here. Problem is, what do I do at the bottom now? I'll have to say something weird like unhandled, or I'll have to like trap or throw an error, right? And that's just not. It's just kind of just inelegant, and like you don't want errors being thrown everywhere. You want to explicitly handle everything as much as possible to keep everything simple and to just have a nice clean interface for everything. So that's what's nice about the match, is that I can know that I handled every single case. I don't have to have a weird trap or anything. See, every single case is handled. That's an error. That's an error. Also, you can have a catch-all. So let's say fire is its own thing, but let's say the thumbs are the same. So I can just catch everything that's not fire and say it was a thumb of some kind. And I don't technically need fire if I don't want it, because the catch-all will catch all that. So that's match. That's how you use a basic variant. And then if you do want to have something more, if you want types in here or values at runtime, you can definitely do that. So let's go back to returning a reaction. In this case, I could return an age. So yeah, you can play around with that. The variants can be arbitrarily nested. You can have records and variants in records, all that. And with these tools, you should be able to model, hopefully most things that you would need to model, especially when building a DAO. So you could model your proposals. You could model with a variant if something, the state, right? Maybe the vote state of a proposal. And it could be, open for vote. Pending some kind of finalization. I don't know. Waiting for delay window. Like that, right? There's only a few states that your votes could be in, or your proposals could be in, and so you do not want all of them. You just want one. So that's how you would enumerate it. Okay, now we get to the these types are a little bit weird. You might not ever need to use them, or at least in very rare circumstances. But there's a type called func in Azel and in Candid. And like it says here, func types, I guess Candid itself, they like to support higher order use cases. Basically, you can pass in functions or pass in services into other services so that you can basically call back. You have all the information that you need to make a call back dynamically at runtime. So what the func looks like, when you define it, it is a tuple. And at runtime, wait, you don't define it. Sorry, I think this documentation is wrong. It is not actually a TypeScript tuple. We actually use this very interesting syntax. I think I'll need to fix that. But it will be a JavaScript array with 2 elements at runtime. The first element will be a principal that represents the canister ID. And the second will be a JavaScript string that represents the method of the canister or the service, those being basically synonymous terms. And like it says here, a func acts as a callback, allowing the func receiver to know which canister instance and method must be used to call back. So if you receive a func, you should have the information necessary to create a cross-canister call out to that function. So let's show you how these things work for a func. Yeah, we'll just make a basic func, string func. What you want to do is say whether or not the method that you're calling is a query or an update method. So I don't know, what do we want to call this? Maybe there's like, you want to check if some proposal passed or something. So maybe you'll get the proposal state. In this case, it's just a query function. And the parameters, let's say you do need to pass in the proposal ID. A string, and then it will return you, let's say it like returns a variant. I guess I should have just kept. Yeah, open those or something. Okay, so we've created a func. In this case, we want to get the proposal. So in this case, we are allowing people to call our canister to get a func that they would be able to use. This is very contrived, but how you do that would be create an actual tuple, right? So you can see that it is actually tuple under the hood. And in our case, we are talking about ourselves. So we would grab our canister ID, and then we'd pass in a function that would allow us to get that proposal state. So we would need to define a query function that will return the proposal state given a proposal ID. And we'll just hard code it to be open, but you would use this proposal ID and go to your data storage and grab it. And we put this here. This is how you define a func. This is how you create a func at runtime. Now, how would you actually use a func when you get that func? Unfortunately, so dynamically, you would have the ID that you need, and you would have the method name. You do not, however, have the parameter and return types. So you would need to have this information, which will be compiled to Candid. So let's deploy this, and I can show you what it looks like in Candid. So you would need this information to basically create a service, or if you're using so we haven't talked about cross canister calls yet and how to call other canisters, but there's a couple ways to do it. One is to define a service where you statically define everything about the service, the method names, the method types, and the return types. Another way, though, if you want to do things dynamically, is to use a raw call. And a raw call just expects candid bytes. And so maybe that could work for you if you do have these parameters stored somehow just as bytes without the type information. You could do a raw call like this. I see that call raw. And um, let's assume someone was passing in to you. And you would have the ID right there, and then you'd have the method as the second parameter, and then you would have to pass in your args as just raw bytes. And how many cycles you're sending. So that is one way that you could use a func as well. So yeah, I'm just showing you how to make funcs, how to use funcs, but really diving into funcs, I guess, would be maybe its own lecture to go with cross-canister calls and such, which we will have, I believe, a lecture on cross-canister calls. And service, so we were just talking about that. But if you do want to talk to another canister, then you would create something called a service. It represents the service type, which you can go see more about here. A service is a canister. This is how you're going to talk to other canisters, right? This is the basic mechanism. How do you do it? You make a class. You extend the service type that you import from Hazel. And then you define every method on that service. You mark it as either a query or an update function. And you need to mark it as a call result with the actual type that it returns. So that's how you make one. You instantiate one like this. You the name of it and you pass in the ID. And if you actually want to make a call, you use async await. Just mark your function as async. And then if you get past the service, you can actually just await a method call. So you call the method and then you call .call. And that's the basics of a service. And you can pass these around. You can, they can be accepted as parameters and return types. And you can just make them for your own self to pass them into other things. We have a number of other canisters. We have a number of services that are already created for you. So for example, the management canister. This is a service that already exists. And it has a lot of functionality to do Bitcoin stuff, to do tons of Internet Computer APIs. And that service is something that you would have to write, but we did it for you. If some functionality doesn't exist, like some service to interact with some other canister, you don't need to wait for anyone to build it for you. You just define it yourself. And you can go see over here how this is done. We just made a class called management extended service, and we went and found the candidate for these canisters, and we just basically copied them over. So nothing is too crazy here. So that's services. The principal type. We talked about this yesterday a little bit, but these are basically identifiers. It's the common scheme to identify canisters, users, and other entities. So basically, it's an ID called the principals. At runtime, it's going to be an actual at Dfinity principal. And pretty easy, you just import those from Hazel. You make one like this from text, or I think they have from hex or bytes or other things, but that's how you would make one from a text principal. Nothing crazy. Again, parameters and return types, you can receive them and return them. And then we have these really weird types at the end, reserved and empty. I mean, you can just go read about these, but reserved lets you mark basically a parameter as no longer existent. And it will be the any type in TypeScript, and then at runtime it will just be null. It's according to our documentation. I would have to double check, make sure that's still the case. I believe it's a good guess, though. I mean, you're really not. You might use this thing if you really think like you need to use it. Then go study the documentation here. It's a very weird type. And empty is also weird. It has no JavaScript value at runtime because empty means that value will just never exist. So, for example, if you mark a parameter as empty, then you literally can never call this function because there is no value that can't be empty. And yeah, it's a little weird, but you can go study here more. It's just the absence of any possible value. And even they say practical use cases for the type are relatively rare. It could be used to mark a method as never returns successfully. And I'm not sure why you need to use it, but it is there for you. And that's everything. We went through every single type. So I guess I'll stop there for the moment and see if there are any questions.
Amazing. There is one question in the Q&A. I think it's from the beginning of the presentation, but blob can be used to store base64 images. Can blob be used to store base64 images?
Blob can store, it's a uint8 array. So if you can convert your base64 image into a uint8 array, and it's under 4 gigabytes, and ASIL doesn't run into the cycle threshold limit, then hopefully that would work. You just need to try it out.
Okay. There is also someone asking if the function is the same thing as a delegate.
Delegate in what sense? Like what language are you talking about, and
I'm not so sure.
concept? Delegate?
Maybe the person can
Yeah, if
explain.
you can explain more what you mean by delegate. I'm gonna say probably not. I mean, it's just a function. It's a function. It's a higher order function. It's a callback that you can pass around. It's a first class function that you pass around. So it's a very, very, very common concept in JavaScript and in many languages now.
How do we, okay, so if services are created with interface, as you explained, how do we connect with other ecosystems? Like, let's say the person wants to connect with Chainlink or with Bitcoin.
So I'll share my screen. So a service is just to talk to other canisters, right? If you want to talk to something that is not on the internet computer, then you need to do something entirely different. I'll show you how to do something like that. So talk to Chainlink, that's what you want to do. There's a couple ways you could do it. But first you'll need an async function. Return to promise. And then what you do is you use the management canister to make an HTTP request. That is the basic answer. If you want to talk to another system, then you need to use an HTTP request. Otherwise, there's no way for the internet computer that there's no functionality that the interpreter provides that would let you do that. So you could talk, if Chainlink has an API, like Web2 normal API, you can just put that URL in. Or you could talk to Ethereum nodes, right? Here's an example that shows you how to talk to Ethereum. So I'll just show you these two examples real quick. So here's the Ethereum JSON RPC example. Notice I am using the management canister. I call HTTP request. I pass in my Ethereum URL. I pass in that it's a post, put some max response bytes on it. I don't have any headers. Turn my body into encoded UTF-8 like I need to, and I just call the JSON RPC API right here. And then you provide a transform function to transform. It's to make sure everything's deterministic. So it's not a deep dive, I'm just showing you. This is how you could talk to Ethereum. And then, so you could talk to you could query the Chainlink smart contracts through this type of mechanism. Or if you want to just do HTTP requests to normal Web2 APIs, you could look at the outgoing HTTP request example. Again, we're going to use management canister, but we'll just do a normal HTTP request. For example, this is to the XKCD API. So I just pass the URL in, and this time it's a GET. And I don't have a body, I don't have any headers. So that is how you talk to other systems.
There is a question about using HTTP requests to, I think the question is about using HTTP requests to talk to other canisters. And then if it would be more efficient to do an inter-canister call.
What's the question in the chat? What is more efficient? Inter-canister call?
Yeah.
Inter-canister call. Yeah, inter-canister calls within a subnet will be probably the cheapest. The HTTP requests, I think they're going to be quite a bit more expensive. And then what was the other question? Essentially,
the person was asking if we could use HTTP requests to talk to another canister, but I don't see any scenario where you
could. But you could, and there's like, for example, there are some rules about how messaging works on the NNS and such, and someone suggested that you could use HTTP requests to like get around this rule. So there could be reasons why HTTP requests are handled differently than other types of requests. So you might be able to use that to do certain things. But yeah, generally that'd be a little bit strange to do.
Okay, thanks. More questions? Okay, if you have a setup issues, we'll see that in the mentorship session or on Discord. Okay, well, thanks, Jordan.
You're welcome.
Okay, so next mentorship session in 3 hours, and see you guys. Keep working, keep building. See you.